This is a recording of the last problem for section 13.2, which is about bicycle sales, and in which we're going to find the maximum weekly revenue, maximum weekly profit, and then finally the price the company should charge to realize their maximum profit. So the given problem says that the company manufactures and sells bicycles. Their cost function, C of Q, is equal to 10 plus 5Q plus 1 over 60Q to the third power, where Q is always a positive number because you don't make negative numbers of bicycles per week. And Q represents the number of bicycles, and P represents the price per bicycle, which is dependent upon the demand. So P is equal to the demand for Q units, which is 90 minus the Q units for the bicycles. So your revenue is always Q times P. And we have an expression for P, and what we need is to find an expression for the revenue based upon that. So since the revenue is Q times P, revenue is going to be Q times 90 minus Q, which is 90Q minus Q squared. Now, the rate of change of revenue is going to be the derivative of revenue, and where the derivative of revenue is equal to 0 is where we're going to find the maximum weekly revenue. So first we need to find R prime of Q. And R prime of Q is going to be 90 minus 2Q. And 90 minus 2Q is equal to 0. When 90 is equal to 2Q, which then means that Q is going to be 45. So what that means is that 45 is what we call a critical number. And now that we've got the critical number, we need to determine for sure that the derivative actually is at a maximum at that point. So what we're going to do is we're going to test a number on both sides. So we will draw our number line. And place the critical number, which is 45, on that number line, realizing that that number line actually, I shouldn't start it with an arrow, I should actually start it at 0, because that's the least number of bicycles that we can make. And then testing a number on either side, we will test 40 and we will test 50 and see for sure whether Q, being the only critical number, is a maximum or a minimum. And R prime of 40, and you can verify this on your calculator, R prime of 40 actually turns out to be positive 10. So on this side, your derivative is positive, 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 which means your function is in fact going up. And then R prime of 50 turns out to be negative. In fact, it's negative 10. So that means that the derivative on this side of your critical number, which is 45, is negative, 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 which means that your function is going down, and that tells you that your maximum revenue occurs when you have made and sold 45 bicycles. Part B wants us to find the maximum weekly profit. So in order to find the maximum weekly profit, we need to subtract the cost from the revenue. So profit, which is P of Q, is equal to R of Q minus C of Q. And since R of Q is P times D of Q, is P times Q, then that is 90Q, again, remembering how we did that in the last problem, 90Q minus Q squared, number of units times the price per unit, minus the cost, which is given to us in the setup of the problem. So that's going to be minus 10 plus 5Q minus 1 over 60 Q to the third power. So then our profit equation, once we clean everything up, is going to be minus times the negative 1 over 60 is going to be this is positive, it is not negative. So minus times positive means we have negative 1 over 60 Q to the third minus Q squared (90 minus 5 is plus 85Q), and then minus times 10 is minus 10. So our profit equation, P of Q, is equal to that. So for our next step, to find the maximum weekly profit, we're going to need to find the derivative of profit. So the derivative of profit is going to be P prime of Q, and that's going to turn out to be negative 3 over 60, which is the same as negative 1 over 20, Q squared, minus 2Q, plus 85. And we will set that equal to 0 to determine where the maximum profit actually occurs, what the critical number is. Now, the best way to solve this problem is using quadratic formula. And just as a reminder, your quadratic formula says in order to find the value of Q that you're looking for, you're going to take the opposite of the middle term's coefficient, which is the opposite of negative 2, which is positive 2, plus or minus the square root of negative 2 squared minus 4 times negative 1 over 20 times 85. And I don't quite have enough room to get that all on there, but you do have your quadratic formula elsewhere, so please just fill in your quadratic formula and find out that the formula gives two solutions, actually. The first solution is that Q is equal to 25.8. It doesn't come out to be an integer value. And Q equals negative 65.8. And the negative answer doesn't make any sense because we can't have a negative number of bicycles anyway. So our maximum profit is going to be at 25.8, or that may be our minimum profit, but what we'll do is we'll actually do again the number line test. So we'll draw a number line. And 25.8 is our critical value. So what we're going to test is we're going to test $25 and $26, and what you'll find out is that when you find P prime of 25, that is in fact greater than 0 or positive, and that when you find P prime of 26, that is in fact negative. So that means that your function is going up and then going back down. So 25.8 is your maximum, and since at 26 you're actually going to be losing money, then what you want to do is you want to make 25. So Q equals 25 will maximize your profit. And then plugging that into your profit equation, which is P of Q here, what you'll find is that P of 25 is equal to $1,231.07, which is your maximum profit that occurs when you make and sell 25 bicycles. And the graph here at the bottom of it simply shows that what happens, sometimes it's counterintuitive. You think that you should make your maximum revenue should make your maximum profit, but notice here, maximum revenue actually occurs out here, but your maximum profit actually occurs back here at 26, because that's when your revenue is highest above your cost. So it's a little counterintuitive sometimes. So always remember, you need to find your profit equation, and don't just count on maximum revenue to make you the best money.